Hello viewers, I am Kausalya. Today we are going to discuss about test signals in control systems. So, what is a test signal? A test signal, here as the name indicates, we are going to use some signals in order to test a system, right? So here, these signals are used to predict the response of the system. So what is mean by response? Response is nothing but output. So whenever we are giving some signal, we are going to check what is the output of the particular system. That's it, right? So there are various types of standard signals, totally 5 types. So step signal, ramp signal, parabolic signal, impulse signal and sinusoidal signal. So totally we are having 5 types of test signals. So here, where these test signals are generated, these test signals are generated in the laboratories. Okay, we can easily generate these 5 types of signals in laboratories, and finally we can use these test signals to check the performance of a system. And again, the test signals are functions of time. They are represented as a functions of time because here in this chapter we are studying each and every term in terms of time. Okay, this is time response analysis. And now we are going to discuss about each and every type of test signals. And the first one is step signal. So here, a step signal is that whose value changes from 0 to a when t is equal to 0. That is, when the value of time is 0, the signal value gets increases from 0 to a, right, when t equal to 0. And when the value of t is greater than 0, for example 1 minute, 2 minute, 3 minute or whatever may be, when the value of time gets increased like this 1, 2, 3, here the signal, that is the step signal, remains constant. Okay, it doesn't get varied, just like a steps in a staircase. Okay, it remains constant. So here a step signal is nothing but whose value changes at t equal to 0. When t is equal to 0, its value will get changed, and once when t is greater than 0, the value remains constant, right? So how to express this one mathematically? Here you see, mathematically R of t is nothing but A into U of t. That is, output is nothing but some A into U of t. Here A is nothing but the magnitude, right? This is the magnitude of the signal. So A into U of t. So here, what is the value of u of t? U of t value will be equal to 1, right? When the value of u of t is equal to 1, what about r of t? R of t value will be equal to a, right? Because u of t is 1. So 1 into a equal to a. When this will happen? When the value of t is greater than or equal to 0, right? Its value gets changed at t equal to 0 and it remains constant when t is greater than 0. And the next thing is again r of t is equal to, you see, substitute the value of 0 here. So 0 into a will become 0 when this will happen, when the value of t is less than 0. Right. So this is our step signal. And the next one is ramp signal. So ramp, I hope you heard about this term ramp. Ramp is nothing but a slope, right? Even in hospitals we will have ramp type for climbing up first floor or second floor. So here this is the slope. So you see, when you keenly observe the graph, it's where the slope increases linearly, right? That is, when the value of t increases, automatically here the magnitude also get increases. So ramp signal is a signal whose value increases linearly with respect to time. So when you express this one mathematically, again r of t is nothing but a into t, right, when t is greater than or equal to 0. So this signal also starts at t equal to 0 and it keeps on increasing. So again here substitute the values. When you substitute the value of t equal to 0, what happens? 0 into a, it again becomes 0. So this is your first point. And the second one, just substitute the value of t equal to 1. So when t is equal to 1, what about r of t? R of t will be when t is equal to 1, r of t will be equal to a into 1, right? A into 1, which is nothing but a. Again, when t equal to 2, what about r of t? So r of t will be equal to, r of t is equal to a into 2, which is equal to 2a, right? So just substitute the values here. When t equal to 1, the magnitude is a. And again, when t equal to 2, the magnitude is 2a. So this slope varies linearly with respect to time, right? So that's all. And we are going to see about the parabolic signal. So here, when you consider parabolic signal, again here as the name indicates, the parabolic signal, you see the graph also resembles a parabola. That is, one half of the parabola is drawn here. So here the value varies as square of the time. Okay, here the difference is the value varies as square of the time. So when we represent this one mathematically, you see here r of t is equal to square of the time, right? So at square by 2 when t is greater than or equal to 0, and which is equal to 0 when t is less than 0. Let me explain this one. Again the same thing, just substitute different values of t and calculate what is the value of r of t here. So again, when t equal to 0, when t equal to 1 and t equal to 2. Let us take these three values. So r of t will be equal to, it is nothing but, when t is 0, when you substitute t equal to 0, the entire term becomes 0. So r of t is equal to 0. And again, when substitute the value t equal to 1, when you substitute here 1, what it becomes? R of t will be equal to a by 2, and a by 2 is nothing but 0.5 times of a, right? And again, just substitute the value of t equal to 2. So when you substitute t equal to 2, this will become a into 2 square by 2. So 2 will get cancelled, and finally we will be having 2a. Just plot these values in a graph. That is, when t equal to 0, r of t is 0. So this is your first point. When t equal to 1, r of t is equal to 0.5a. So this is your second point. And when t equal to 2, r of t is equal to 2a. So this is your third point. So just plot it accordingly. We will get a parabola. Since this resembles the shape of a parabola, the signal is known as parabolic signal, right? And the next thing is, now I am going to tell you what is meant by unit step signal, unit ramp and unit parabolic signal. So here for step signal, the value is r of t is equal to a into u of t. Unit is nothing but the magnitude value is 1. That's it. So r of t is equal to, the value of a becomes 1. So here you will be having r of t is equal to 1 into u of t, which is nothing but 1, right? And here ramp signal, so r of t is equal to a into t. And unit ramp signal, substitute the value of a as 1. So here we will be having r of t is equal to t. Third one, parabolic signal. Again the same thing. You just write down the expression and the value of a becomes 1. The unit parabolic expression will be t square by 2. Right, that's it. And the next one is, we are going to see impulse signal. So what is meant by impulse signal? Here as the name indicates, pulse, pulse is nothing but, it is what to say, it is a type of waveform which will be very high in magnitude and its time duration will be very, very small. Okay, that is known as pulse. So impulse signal is also the same signal which is available for very short duration. Okay, that is known as impulse signal. So here this is the typical graph of your impulse signal. So here in this case, you see the value, that is, this is again in the form of a pulse, and when t is equal to 0, when time is equal to 0, the magnitude is about infinity. This is very, very high. But when the t is greater than 0, its magnitude becomes 0. That is, it is a type of signal whose magnitude is very high in a minimum time for a very short duration. That is, when the time is in terms of milliseconds or microseconds, we are having a signal whose magnitude is very high, right? So that is known as impulse signal. Even we can say lightning as a best example for impulse signal. And while representing it in mathematically, you see this is your expression, that is del of t is equal to 0. Whenever the value of t is greater than 0, the magnitude is 0. And whenever the magnitude is, what to say, you see when here t1 is indicated as 0 here. Here minus t1 and plus t1, this is nothing but expressing time in terms of milliseconds or microseconds. That's it. So this is almost 0. So during this time, the magnitude is equal to 1. Right. And the next one is, it is a pulse of small width and unit area. Here for this signal, we are considering the area under this impulse signal as unity. Again, when you take Laplace transform of impulse function, it is equal to unity. Right. Hope you people understand what is meant by impulse signal. So here in this video, we have discussed about what are all the types of test signals. Hope you people understand. Thank you.